Hey, what's going on, everybody? Today we want to provide a little bit of a basic introduction to market structures and begin talking about perfect competition. So when we talk about market structures, we're going to be looking at a couple of different ones, and it really depends on two major factors. First, the number of firms that are in that market. Is it one firm, few firms, or many firms? One firm, right? Think a monopoly. Few firms, think an industry dominated by 2 or 3 companies, maybe Coke and Pepsi for soft drinks. For many firms, we're going to be talking about perfect competition. Now, it also depends on what type of product we're selling, right? Each firm in this industry, are they selling identical products or what we call differentiated products? When we answer these questions, that's really going to determine what market we're in. So let's look at this idea of identical or differentiated products. So pick an easy one to start with. Think about agricultural products. Would you think this is identical or differentiated? The key with this, though, is can you tell one firm's product apart from another? So in this case, if we're talking about corn, can you tell corn from one farm from another? Probably not, right? So this would be an identical product. These are, right, no easy distinguishing way to tell them apart, what we would call an identical product. What about automobiles? Well, there are ways to tell cars apart. We have brand names. We have Chevy, Ford, Dodge. We have red cars, blue cars, 4 doors, 2 doors, sports cars. So here, these are differentiated products, right? This is what we call a differentiated product. There's ways to tell them apart that set them apart from their competitors. What about gasoline? Now, you might be thinking there's brand names attached to that. We have Shell, Exxon. But think about the product itself, the actual gas. Is there a way to tell that apart from any other gallon of gas? And the answer is no. So it's an identical product. What about breakfast cereal? There's lots of ways to tell breakfast cereal apart. There's Lucky Charms, Cheerios, all these different brand names, right? Total, Chex, Frosted Flakes, Apple Jacks. So this is another example of a differentiated product, right? We have a lot of different types of breakfast cereals, right? Clearly none better than Lucky Charms, but that's the story for another day. So our answers to these questions tell us which market structure we're looking at. So are our products differentiated, yes or no? How many firms are there? One, few, or many? And so here, the one we want to start by talking about is a market structure with many firms selling identical products. We're going to start by looking at perfect competition. But it's important that you know these because we're going to talk about each of these sort of in turn. Let's start, though, with perfect competition. All right, a perfectly competitive market is one where a lot of firms produce the same product without variation, and firms can enter and leave that market easily. So in other words, we have to assume the following. There are many firms in the market. They sell identical products, and there's no what we call barriers to entry. All right, there's a lot of different, what we would consider a barrier to entry. Is there any sort of legal paperwork that needs to be filed to be a firm in this market? The answer is yes. That's a prohibitive measure that might prevent someone from coming in to that market. That's a barrier to entry. Again, a good example of a perfectly competitive industry would be farms, agriculture, right? Anyone can start a farm, start growing crops for sale. There's nothing beyond simply having to own a farm that you need to get into that necessarily. So think about barriers to entry as things, legal things that might prevent someone from joining that industry. One thing we do need to know, though, since there are many firms in this market, each firm is what we call a price taker. Now, we talked about this in class, but let's review this concept, right? Each firm in this market are what we consider a price taker because there's so many firms in a perfectly competitive market that each one has such a small share of this that their decisions really don't greatly affect the market. If one farm decides to stop growing corn, it doesn't affect the whole market for corn. There's so many other farms that produce it. So in a price taker situation, firms in a perfectly competitive market, they can't influence the market price. They simply adjust to it, right? So think about our supply and demand graph for that industry. So here we might have the supply and demand, the price dictated to us by the market for corn. Well, that price from supply and demand simply carries over and becomes the price that each individual firm as a price taker is going to charge. So when we talk about a perfectly competitive firm, one of the first things we need to describe it as is a price taker. The market dictates to them their price. So here, for example, would be the price dictated by a firm. So let's say for our particular firm here, that the price is $8. This was given to us by supply and demand. Okay, so we have a price of $8, right? One product is $8. The price is always going to be the same. Now, we did an example like this in class, but let's review, right? What's our marginal revenue going to be for each product that we sell, for each unit that we sell in this industry? Well, remember, when we talk about marginal revenue, we're talking about the change in total revenue over the change in quantity. So notice here as we move from 0 units sold to 1 unit sold, right, our total revenue goes from 0 to 8, right? Total revenue is just price times quantity. So we went from 0 to 8 and 0 to 1. 8 divided by 1, 8. Now, we could go through the whole chart, but we have an interesting thing that we need to point out here. Our marginal revenue is always going to be $8. It's always going to be equal to the price in a perfectly competitive industry, right? Notice, right, that makes our price curve for the perfectly competitive firm as a price taker equal to our marginal revenue. It's also going to equal our average revenue, which makes sense if you think about it, right? Total revenue divided by the quantity is always going to give you the same number. It's going to give you that same, in this case, $8. So when we calculate marginal revenue, that's important because it tells us our optimum output, right? We want to produce, our optimum output rule tells us we want to produce where marginal revenue equals marginal cost. That's going to give us the best production point, right, where the additional revenue brought in by selling that additional unit covers the cost of that additional unit. They break even at that point. Now, we also know, right, that price and marginal revenue are the same thing. So, when we graph this out, right, here's our price, our marginal revenue price, which is also, again, the demand curve faced by a perfectly competitive firm. Our optimum point is where does that equal marginal cost? Marginal revenue equals marginal cost. Here at this example, it's 0.8. That's our profit maximizing quantity, right? But so how do we know? How is that profitable? Now, remember, profit is simply total revenue minus total cost. This is a bit of economic shorthand. We're going to use the pi symbol to discuss profit. It's just shorthand for profit. So when we do this, remember, we have two different ways of measuring profit. Our accounting profit, which is like our bookkeeping, versus our economic profit, includes all of our opportunity cost. Here we're just going to assume, right, that our costs include the implicit cost. So this is the formula we want to work with to determine profitability. Profit is total revenue minus total costs. So when we just use that formula, here's how we make our decision. If total revenue is greater than total cost, the firm is profitable. More money is coming in than is used to being spent on costs. That means we're making a profit. The firm is profitable. If total revenue is less than total cost, we're operating at a loss. Now, we will see later, operating at a loss, right, your natural instinct might say, well, why are they even in business then? Well, we're going to talk about that a little bit later. You may still decide to stay open and not shut down, even if you're operating at a loss. Here, at total revenue equals total cost, we're breaking even. So, we have a general way to calculate profit, but that's not all we want to focus on necessarily. What about profit per unit? Okay. Are we making a profit per unit? So we can do a little bit of math. I know this might look confusing, but just walk through the math, right? We know profit is total revenue minus total cost. Well, what if we did that per unit? So if we did that, right, our total revenue divided by quantity gives us our average revenue. Our average revenue is equal to our marginal revenue. Okay? Total cost divided by quantity gives us our average total cost. So our profit per unit is equal to price minus average total cost. So when we look there, we find that if price is greater than average total cost, the firm is profitable. Right? If the price we charge is higher than our average total cost, we're profitable. If price is less than average total cost, we're operating at a loss. If it's equal, then we're at a normal profit, meaning what we would expect a firm in this industry to make, right? So let's look at the graph again and now add in our marginal cost curve, okay, and our average total cost curve. Notice, right, our minimum of average total cost is equal to our price. It's where marginal cost and average, or where marginal cost and marginal revenue equal. So that's our minimum cost output, our optimum output point. Just so happens to be at our normal profit point as well. So this gives us a clue as how do we examine the profitability of a firm. Let's look at an example, all right, and see if we can do some calculations here on whether or not a firm would be profitable. So we're going to look at Daphne's Apparel Shop. So here's what I would like you to do. I'm going to walk through the question, give you a second to answer this, and let's see if we can do some calculations with profit. So I want you to use the optimal output rule, marginal revenue equals marginal cost, to find the level of output that maximizes profit if the market price for Daphne's Apparel Shop is $9. All right, and at that point I want you to calculate her economic profit or loss. All right, so I'm going to get up and give you a second here, and I'm going to pause the video and see if you can figure out where she is making a profit if the market price is $9. So go ahead and figure that out, and I'll give you a second here. All right, so here I'd asked you, right, to use the optimal output rule, the level of output that maximizes Daphne's profit if she's charging $9 each. So the key to this is to go ahead and maybe jot down and add a couple rows to our chart. So, right, first we know we wanted to calculate our marginal cost. Then we wanted to know what's our marginal revenue. Well, marginal revenue we know is equal to our price. So in this case, it's always $9. We can use that information, our total costs, right, to equal now to figure out where do we have a profit, okay? So, right, total cost for each one is given. We can use the marginal revenue times the quantity to figure out our total revenue. With that, we can figure out a profit, all right? Now, notice, when she sells 0 products, she still has a cost. She has no variable cost, but she has fixed costs. So our profit here, we're actually losing $5. At 1 unit sold, she's losing $2. Again, marginal revenue equals marginal cost, right, happens at the 6th unit. Notice, that's where she's making her most profit, $15 per unit. Go beyond that point to 7 units, right? Notice her profit actually decreases. And eventually she'll start taking a loss again. So when we do this, right, we've noticed that our profit maximizing point is always going to be where marginal cost equals marginal revenue. Okay, that's our optimum output point. So go ahead and make sure you've answered part 1 here, and we'll check back in a little bit later with how to graph perfect competition, take a look at some shutdown decisions in the next video.